In this video we'll be discussing the t-distribution. Let's imagine that we have a population of fish that have weights that are normally distributed, let's say around 5 kilograms. Now let's say that there are 1 million fish in this pond, or in this lake, and the population mean is 5 kilograms. And so the average weight of a fish in this pond is 5 kilograms. It's normally distributed around 5 kilograms. And then let's say we go ahead and we take samples. And let's say in our first sample, let's call it S1, we found that we sampled 3 fish. So I'm going to actually first put N1 is equal to 3. And then the sample is, so x1 is equal to 3, 4, and 5. And so we sampled 3 fish, and their weights were 3 kilograms, 4 kilograms, and 5 kilograms. And then let's say we took a second sample of the same size, so n2 is equal to 3, n meaning the number of fish. And then we found that this sample contained the values 4, 6, and 8. So one fish was 4 kilograms, one fish was 6 kilograms, and then the last fish was 8 kilograms. And then let's say, so for the first sample, let's take the mean. So let's call that x1 bar. And then this is equal to 4. You can see 4 is the center value, 3, 4, and 5. So the mean is 4. And the standard deviation, S1, is, you could see that the average distance from the center, from the mean 4, is 1. Because it's 3 is 1 below 4, 5 is 1 above 4. And so the standard deviation is 1. And then let's do the same for our second sample, or sample 2. So we have mean 2. 2 is equal to, so that's the middle value, 6. And then, so if you took the average, you'll see that it's 6. And then the standard deviation of this, or S2, is equal to 2. See, on average, the average distance from the mean is 2. Now, what we're going to do, we're going to define a value given by t. For the first group of fish, first sample, we're going to call this t1, and this value is going to be equal to the sample mean, so x bar 1, subtract the population mean, which is the population of all the fish, because we sampled from this population. And so subtract the mean, divided by the standard deviation of the sample, which is 1, but we'll just put S1 for now, divided by this value, divided by the square root of the sample size, so square root of N1. Okay, and then we're going to compute the same thing for the second sample, so T2 is equal to the mean of the second sample, subtract the population mean, all divided by the standard deviation of the sample, divided by the square root of N2. And so we're going to go ahead and compute these values. So for T1, we have 4 subtract 5, divided by 1, divided by the square root of 3. So I'm just filling in these values that we have for each sample. And then for T2, we have 6 subtract 5, divided by 2, divided by the square root of 3. And so if we work this out, we see that this first value comes out to minus 1.73 approximately. The first value is minus 1.73. Then the second value, so T2, is equal to 0.866 approximately. And so if we were to make a histogram of these values, so right here, let's make a histogram. So histogram of samples. I'm going to put 1, 2, -1, then -2. So the first value, 0.86, we're going to just put that's right below 1, so right here. Just put a box. So this is 0.86, and then we have -1.73, which is, let's say, right here. Okay, so now notice that we only have two samples, right? If we repeated this procedure, and so let's say we took, let's say, if we take infinite amounts of samples of size n is equal to 3, because notice in both of our samples we had n is equal to 3. We sampled 3 fish on each of our samples, and so if we take infinite amounts of samples of size n is equal to 3, we create a t-distribution with n minus 1 degrees of freedom. So I'm going to just put in parentheses, so n minus 1 is equal to 3 minus 1 is equal to 2. So in this particular example, since our sample size is n is equal to 3, we would have 2 degrees of freedom. And so I want to show you the relationship now of the t-distribution to the normal distribution. Okay. So I'm going to draw here in yellow the normal distribution. So this is standard normal. Then I'm going to draw a second distribution, which represents the t-distribution with 2 degrees of freedom. Okay. Draw that a little better. Okay, so what we're going to do here is we're going to see the difference in the tails of these distribution, because that's what actually makes them different. So I'm going to just draw the yellow is normal distribution mean is equal to 0, STD is equal to 1, or standard deviation is equal to 1. And recall that this is what we call the standard normal distribution, or the Z distribution. And so now what you'll notice is that as the degrees of freedom go down, there is more area in the tails of the t-distribution. And so what that means is this. If we right now look at the area, okay, so I'm actually going to put that in the same color just so you know. So if we look at this area right here, this is the area less than minus 2 on in standard normal distribution is, so I'm going to just tell you the area right here, it's 0.02275. Now, the t distribution with 2 degrees of freedom, so I just write it right here, t distribution with 2 degrees of freedom. Okay. Now, so I'm going to show you this right here. This area right here, which includes the yellow also, so I'm going to just put a stripe over that. So the area less than minus 2 in t distribution is 0.09175. And so you'll notice that as the sample size gets smaller in the t distribution, that is, it has a lower degree of freedom, there's actually more area in the tails. And so the tails are fatter than the tails of the standard normal distribution. And another thing is, so let's say on top of this graph we were to put, so we're going to draw another distribution. Let's say that this distribution actually has five degrees of freedom. So t distribution with 5 degrees, I'm going to just put df. Notice how this distribution is actually closer to the normal distribution. That is, there's actually less area in the tails right here. And so I'm going to write that as sample size or degrees of freedom increases, the t distribution approaches a standard normal distribution. So just to recap here, you could see that with a standard normal distribution you have an area of 0.02 less than minus 2 z-squared. So the area under less than minus 2 is 0.02, and then as you increase the degrees of freedom, this area, as you decrease the degrees of freedom, the area increases. And as you increase the degrees of freedom, the t distribution approaches a normal distribution. As you could see with the purple line, that this is a t distribution with 5 degrees of freedom, and it's closer to the normal distribution. And as you keep going, and you get to a sample size of about 30 is used, is where it starts to become very, very close to the normal distribution. And of course, if you go to infinity, take the sample size to infinity, then it is identical to the normal distribution. And so this has been a video on the t distribution, and thanks for watching.